The sun is shining. The air is crisp and clear. The brilliant mountain stands out in sharp contrast against a sky of deep ultramarine. For nature lovers, the Smoky Mountain is a true paradise filled with umpteen surprises, aromas, and mist. A visit to this mountain is a must and in the top 10 places to visit. Well, you must be thinking the narration doesn't really match the visuals. But this is where we are heading to, and our future generations will have to deal with such waste mountains. We all need to manage our wastes ourselves. A few leading institutions such as the Art of Living International Centre in Bengaluru, the IIT Gandhinagar campus, and a residential township in Mumbai show us the way. Let's see how. The Solid Waste Management Rules 2016 laid down the guidelines for urban local bodies and all waste generators in urban areas on their roles and responsibilities. These rules also spell out special provisions for waste management by bulk generators. Bulk generators are typically those that produce more than 100 kg of waste per day. This could include schools, residential societies, educational institutes, hostels, hotels, marketplaces, or places of worship. These institutions are the key economic drivers in the city. These campuses are also one of the major contributors of solid waste in the city. A large portion of waste from such campuses comes from their kitchens and is mostly biodegradable. The Municipal Solid Waste Rules 2016 state that institutions and gated communities with an area of more than 5,000 square meter should process their biodegradable waste at the source using composting or biomethanation techniques as much as possible. We take the case of 3 such decentralized waste processing units. The first such campus is a spiritual center, the Art of Living International Center in Bengaluru, which uses the biomethanation plant made by GPS Renewables Private Limited. The second campus is one of the premier educational institutes in the country, IIT Gandhinagar, that uses the Nisargun technology to convert their kitchen waste to fuel. And the third is a residential society located in dense Mumbai that composts its waste on the rooftops. The Art of Living International Center is a sprawling 65 acres campus. It has a 10,000 square meter kitchen with 40,000 square feet dining area. This generates about 1,500 kg of food waste at the ashram every day.
There is a plate leftover food which we cannot distribute anywhere. Which has to be. We were doing the composting out of it. Food was in a huge amount. So we thought of installing it, this kind of plant, so that we can utilize in a much efficient way.
The center decided to install the Bio-Urja plant. The Bio-Urja plant is one of the products of the Bengaluru-based GPS Renewables Private Limited.
The vision with which this company was founded was to help find a solution to tackle the waste, which is a big problem in whole of the country today. We believe that decentralized waste management is the way to go. We started with our first product, Bio-Urja. It's a completely prefabricated, automated solution specifically designed to coexist with people.
A Bio-Urja plant of 1 ton per day capacity has been installed in the center since 2015. The plant not only treats the biodegradable waste generated in the ashram, but also provides alternative fuel equivalent to 70 kg of cooking gas. This is roughly equal to 5 LPG cylinders. This plant of 1 ton per day capacity is housed in a very small space of 20 square meters. The kitchen waste from the center's kitchen and dining hall are inputs to the Bio-Urja plant. After the waste is collected from the kitchen and dining hall, it is brought to the biomethanation plant. The shredder cuts the waste into smaller pieces, and the screw pump feeds the shredded waste into the pre-digester. Here, hydrolysis takes place and the waste is converted to acids. The acids are then fed into the digester, where anaerobic digestion takes place to produce gases. The gas produced primarily consists of methane, carbon dioxide, moisture, and trace gases like hydrogen sulfide. The hydrogen sulfide and water are removed by two separate scrubbers. From here, the gas goes to the twin balloon system, where the biogas is temporarily stored. After this, the gas is transferred into the pressure storage vessel for permanent storage. The output from the plant is biocompressed natural gas or CNG, which is used as fuel for the kitchens on the campus. A major concern for many campuses is the ability to operate, maintain and troubleshoot such plants. The Biogas plant addresses this concern through remote monitoring of the input waste. The automation system controls the gas storage, compression, and also flares any excess gas. The cloud-based dashboard collects data on the plant's health parameters and operational parameters like flaring rate and gas produced. The system also alerts if the quality of waste input to the plant is different from the desired quality.
So we typically look for semi-skilled persons for the operation of the plant. Training wise, once the plant is set up, so we give a 10-day training to the client designated or nominated people. So typically we look for a group of 4 to 5 people for the operator job and another 2 to 3 people from the engineering staff.
The capital cost of the plant is about Rs 30 lakhs. The total operation and maintenance cost of the plant comes to roughly Rs 14,000 per month. The payback period for the capital expenditure of the plant is about 2.5 years.
From the kitchen leftover food, the segregation is not required as much. But when the dining hall it comes, the segregation, we have kept the twin bin system in the near the dining hall, so that leftover food can go in the one bin and the other one, the plate used, should go in the other bin.
One of the major challenges to the smooth functioning of the biomethanation plants is the availability of segregated waste. This challenge has been successfully overcome by IIT Gandhinagar. Located on the banks of river Sabarmati, the Premier Institute is well known for encouraging its students to engage actively with social issues.
We would like our students to graduate with the right values and right attitudes. And therefore, it is extremely important that they see us doing right things. If we as a campus will not maintain ourselves well, if we don't do the right things, we will not handle our waste in a sustainable manner, we cannot expect that we will train our students to do so when they go out of our campus. So to us, it is an extremely important agenda.
In order to achieve this objective, IIT Gandhinagar started the initiative of becoming a zero-waste campus. The institute introduced segregation of waste across its campus. All the waste generated in the campus is collected in 3 color-coded bins: green for organic, blue for recyclable, and red for landfill waste. All wet waste generated in the kitchens along with leftover food waste is collected in the green bins. This wet waste is treated in the Nisargun biomethanation plant, which has been developed by the Bhabha Atomic Research Center.
The biogas plant in IIT was started in 2016. It has a capacity of 1 ton per day. The waste from the campus, from the canteen and from the residential area comes here twice a day.
The organic waste generated in the hostel messes, kitchens and residential areas of the campus is brought to the plant and weighed. This waste is then fed into the 3 to 5 HP mixer to convert it into slurry by chopping it into finer particles and mixing with water. This waste is then fed into the pre-digester tank, where aerobic digestion takes place. After pre-digestion, the waste enters the digester tank, where anaerobic digestion takes place to produce biogas, whose main component is methane. The plant produces biogas equivalent to 2 cylinders per day and 0.08 to 0.1 ton per day of manure. This gas is used in the IIT campus to generate electricity using a converter. The gas can also be used for cooking directly. The plant requires a space of about 80 square meters. The installation cost of a 1 ton per day Nisargun plant is Rs 21 lakhs, while the running cost of the plant is Rs 2.1 lakhs per year.
From the management point of view, it has been interesting to see that although it is fairly easy at a resident level, but you have to put in a lot of extra time to make sure that the residents are all on board with your policies, that you sensitize the community, that you communicate with the community on a regular basis. That has been a very important aspect of learning about waste management.
Continuous communication also has to be accompanied by regular audits to ensure that the segregation is continuously carried out by the campus.
On the whole, my impression is that about 80% of the solid waste that the campus generates, we are able to manage it inside. The story does not end here. When an important visitor comes to our institute and when they see some of these practices, when they see what we are doing, they realize that we are a different institution. They realize that we are serious. They realize that we mean what we speak. They realize that we walk our talk. And as a result of that, their image of us, their impression of us improves. They go and talk nice things about the institute, which helps us attract better faculty, which helps us attract better PhD students, which helps us attract more funding for our research. So I would say while the right things for waste management can be helpful by itself, because it is the right thing to do, but it also helps in our teaching and in our research.
Other than such large-scale campuses, waste processing at decentralized level can also be done by housing societies in the city through composting. This concept is already being used by the Vijayanagar Society located in Mumbai.
Under the Zero Garbage project, initially we just decided to segregate the wet garbage and dry garbage.
Managing committee put up a board and we all volunteers come together and we took a wing-wise presentation. We give them pamphlets, we give them dustbin.
So compost pits were constructed. All these compost pits are, we have 8 here with us. For aeration, we have pipes in between. We have proper drainage system for that. So after whatever water drains out, that goes to drainage. And they have got gauze lid. So with that, so that rodent should not enter that compost pits. And once the pits were ready in the month of December, after that, on the 1st January, before 1st January, we actually educated people to give the segregated garbage as well. So they started giving it. Our housekeeping agency boys, they collect the garbage separately. And on the 1st January, we actually started the composting procedure at all pits with the help of these Bhaginis. These are Sri Mukti Sangatana's Bhaginis. 3 of us are been employed in our colony. So every day they come here and take care of this composting procedure.
The apartment incurs an additional cost of Rs 26,000 per month on salary of the Bhaginis and around Rs 5,000 for materials over 6 months. Additionally, a maintenance cost of Rs 5,000 is also incurred per month. These campuses show that implementing segregation at source and investing in wet waste processing technology can help in diverting bulk of food waste from going to landfills. The Bio-Urja, Nisargun plant, composting, thus are good examples of closed-loop systems. Such decentralized treatment helps the ULB save on transportation costs, reduce the burden on landfill sites, and will also help in energy generation. These technologies provide an easy solution for bulk generators to manage their wet waste at source and reduce their carbon footprint. This can easily help bulk generators comply with the MSW Rules 2016 and contribute to the Swachh Bharat mission. We must realize that we are part of the problem. We all create waste, and it is our responsibility to manage our waste. It is only when each of us does our part for managing waste will India truly become Swachh Bharat.
जाग उठेंगे भाग्य हमारे, स्वच्छ बनेगा ये भारत।